Okay. I just want to inform you. I boken så pratas det om att Thales theorem är någonting annat än det du pratar om integration.
So I saw
Eller
your...
ungefär.
No, we don't do that. I told you. I write everything on the school stuff. If you follow the Polish pages, you are supposed to study. So there are two theorems for Thales. One of the theorems is the one that you mentioned. The other theorem is the one I mentioned. Yes. So both of them are called Thales theorem.
It was just confusing since it's said to prove Thales theorem, and in the explanation it talked about the other, which we have not said is Thales theorem.
Yeah, I didn't know even that is called Thales theorem.
How do you spell it?
Pardon?
How do you spell Thales theorem?
Thales is the name. Yes, so I didn't know about that theorem that you mentioned. When I checked it, yes, you are right. That's also called Thales theorem.
Yeah, exactly.
So apparently this guy has more than one theorem. So
This.
Yeah. I knew. Yeah, I didn't know about that. It's called Thales theorem.
Well, I didn't either. No?
Okay.
Wheeler.
So thank you. You are here now. There are only 13 of you here. I think so you can join. So let me just repeat what we started, and I want to solve some level 3 questions, and then I will give you the rest of it this session to study on your own. There is only one session left, section left, and that is called congruence, and then we will finalize it tomorrow. Yeah. Okay, so let me review what we learned last time. So let me just review what we learned about this bisector theorem. Yes. So if I have a triangle, let me call it ABC. And then let me denote this by little c and this little d. And then I draw the bisector of the triangle. For example, let us consider this bisector. Draw that bisects the angle A into two equal pieces. And this will go and intersect the opposite side at some point D. Yes? So what I know is that A1 is equal to A2. So we know that. So what we want to show, this is the question mark. So I think let us follow the book. Let me call this part X, and let me call this part Y. So what you need to know is that the ratio of X over Y is equal to the ratio of C over B. Okay, so this is the theorem. It's very important and very simple. So you have a triangle. Of course, there are three bisectors. You just, for example, take this one and draw it. It will intersect the opposite side at a point. Of course, there is no guarantee this point is in the midpoint. As you see in this picture, it's not the midpoint. So someone asks you, what is the ratio between X over Y, the ratio of X over Y? This becomes exactly equal to the ratio of C over B. So we want to show that. Yes, let me follow the book's method. Because if you remember, we solved it in two different ways. Let me repeat what is written in the book as well. So what we can do, we can start from this point, for example. If you remember, the previous session I did it from this one, so let us repeat it now from this point. So if I choose this point, I draw a parallel line. I draw a line which is parallel to this side. So hopefully it seems parallel, I don't know. But I just draw this line to be parallel to this line. Yes? This is at least my intention, even if it doesn't work that well. So we draw this line parallel to this side, and then what we do, we just continue this bisector. So it seems that's not a very good, because it seems much bigger, yes. Okay, let us just do that. Okay.
It doesn't matter.
So hopefully you understand what's going on. So that we call it E. By the way, is there any guarantee that I get an intersection point? Yes, because these two lines are parallel, and because this line is intersecting one of these, it will also definitely intersect the other. So you need to, in principle, write these things. You should say that we draw a line from point C parallel to side AB, and we continue the bisector from side D so that it will intersect this parallel line at E. So what we want to understand first we want to show that this big triangle that you see here is an isosceles triangle. This is the impression. This is what we want to show. Okay, so how should we show that? We would say we want to concentrate on this angle. And I want to show that this angle is equal to this angle. If I can show that these two angles are the same, then it means that the triangle ACE, this big triangle, is an isosceles triangle. Then it means that the length of EC is exactly equal to the length of CA. But that is easy if you remember this word Z. If you see there is a Z here going on, yes?
Z.
There is a, yeah, something like this. If you have something like this, it means that these two are parallel. You immediately can conclude that these two angles are the same. So if you just broaden your point of view and see that this is actually somehow similar to Z, then it means that you can immediately conclude that angle. So I would write it. I would write AB is parallel to EC. And you need to write that AE is, I don't know why I wrote transverse. It should be transversal. So AE is transversal. Transversal. And then this implies that angle A1 is equal to angle E. So this means that in this big triangle, AC is equal to EC. So CE is equal to CA. So this means that CE is also equal in size to B. So now I am on the safe side. I can simply write B on it because now I am sure that this size is also B. Yes? But now I forget about this part and I concentrate on these two triangles, meaning triangle ABD and triangle DCE. So let me try to bring this into your attention. So now I want to concentrate on this triangle here, this one and this one. And I'm claiming that these two are similar. For showing that these two triangles are similar, one of the methods which is more popular is two-angle theorem, yes? So, of course, we just learned that E is equal to A1, so we don't have any problems. Okay, so I was a little bit careless. It was correct, but it is not finished yet. I don't know why you didn't say something to me. So A1 and E are equal.
Yeah.
Yes, but I need to write it down. A1 is equal to A2. I just was in a hurry. So A1 is also equal to A2. I have to use it, yes? From this parallel and transversal one, I realize that A1 and E are the same. But my goal is not to show A1 and E are the same. My goal is to show A2 and E are the same. So then I write A1 is equal to A2, so I can conclude that E is equal to A2. So this I actually was in a hurry. So you have to write that as well. Okay, now everything is good. So here we know that angle A1 is equal to angle E. And then we know that this angle, which I call it D1, for example, let me call D1, is equal to this angle, which I call D2, because they are vertical angles, yes? That's the definition of vertical angles. So the angle D1 is equal to angle D2. So then this means that by angle-angle theorem, the triangle for example, the smaller one, ABD, is similar to the triangle EDC. Okay, when the triangles are similar, so the ratio of the corresponding sides are the same. The ratios, yes.
Also,
Yes.
is ACE is also a isosceles.
Yes, HCE is isosceles. That's the only isosceles one. So if you want, I can show it. I wrote that CE is equal to CB. So it means this bigger one is isosceles. This is the only isosceles one that we can use. And that's the reason that CE is equal to B. Okay, so now we would say that the ratio of C, so this means that if I want to write the whole ratio, so I don't need all of them, but let me just do for practice. If I write AB from the smaller triangle, what should I write below it from the bigger triangle? Can you see that? In your head, you should be able to rotate it.
Why?
Yes?
Yeah.
Yes?
Why?
No.
No.
What? Yes, easy. Because if in your head, if you rotate it, this becomes something similar to this. Yes? Yeah. So this becomes D. I don't know. This becomes A, and this becomes B. Yeah. So if I don't know, you need to understand what is going on. So this. Another way is that C is opposite to D1. D1 is equal to D2. Opposite to D2 is B.
Right.
So that's also one way.
Now
so
I see it.
AB in over CE. Okay? Okay, if I write BD from the smaller one, what should I write below it?
Why?
Why? Because BD is opposite to A1. A1 is equal to E. Opposite to E is DC, which is Y. So let me write DC for the time being. This is enough. But of course, if you want, you can write the last one for practice. We don't need the last one. So if I want to write the last one, it becomes AD over what? AD over?
DE.
DE, yes. But we don't need it. So we don't need it, so let us forget about it. Instead of AB, now I can use this small letter. Instead of AB, I can put C. Instead of CE, I put B. And instead of BD, I put X. Instead of DC, I put Y. And that's exactly what I wanted to show. But of course, if this one is equal to this one, it is clear that this one is also equal to that one. And that's exactly what we want to understand.
Wow.
This is the proof given in your book. If you remember, I did it a little bit different. And I used this vertex last time. So you see that you can have the same kind of reasoning from the other side. Okay, but you shouldn't get confused how to write these. So let me, for example, change the picture for you. What happens if I have this scenario? If I have, let me just draw this, for example. If I have a triangle here, okay, let me this time try to draw the bisector of angle B. So if I draw the bisector of angle B, assume that this B1 and B2 are the same. Of course, we just pretend that they are the same. Okay? So then this part becomes X, this part becomes Y, and this is C, and this is little a. Okay, how can I write my relation now? So I want you to learn if the picture is in different directions, you shouldn't get confused, yes? So here, I write the length of one part over the length of the other part. So here I can do the same thing. If A1, so there is a big if B1 is equal to B2, then if you want to, and if you think it is useful, then you can write something for X and Y. You can write X over Y. Then can you tell me what should I write in front of it? You need to understand what is going on here. Here, X in the numerator, y in the denominator. So when you want to write here, x is adjacent to c, y is adjacent to b.
C over A.
So here it was c over b, but you are saying c over a. Yes, you are right. In this case, we have to write c over a. Why? Because x is adjacent to this side, y is adjacent to this side. So if you write x over y, you also have to write the adjacent sides. If I ask you which side is adjacent to x, you would say c. And if you say which side is adjacent to y, you write a. So this is the correct way, yes?
Could you flip them?
Yes.
Y over x
Yes.
equals a over c.
Yeah, that's algebra.
Okay.
You can write with y. That's correct. You can, if you write y over x, you have to write a over c. So that's exactly my point. So let me draw another picture for you. So what happens, for example, if you have this? Yeah, this is more or less the same thing. So I don't know. For example, you have this triangle, and then you have this bisector. So this is C, this is B, this is A, and I have C1, C2. Assume that they are equal, and this is D, and this is X, and this is Y. So this becomes A, this becomes B. So for example, if I want to write Y over X, if of course C1 is equal to C2, then what can I conclude? Y over X is equal to what?
B over A.
B over A. Yes? That's a very simple task. Okay, so let me give you an example here. Okay, so make it a little bit more interesting. So for example, in this picture, in this figure, so I have A, B, C. So let me say that this is 5, this is 8. And then I draw the bisector, for example, from here. It will intersect here. So this is A1, A2. I give you this fact that A1, assume that A1 is equal to A2. And I also give you the whole BC to be 12. And now I am asking you to find X, and I ask you to find Y. Yes? So I have just given you some information on the picture, and I have emphasized that A1 and A2 are the same, so you can use this theorem. Be careful, you can only use this theorem if angle 1 is guaranteed to be equal to angle A2. If not, you are not allowed to use that in the first place.
Babak,
Yes?
point D is not exactly in the middle of the
No,
BC.
we don't know. It might be or not. But in this triangle, it is not. If that's an isosceles triangle, then it becomes exactly in the middle. Otherwise, it is not.
Okay.
Okay, so what we should do here, you see there are two unknowns, yes? Because x is not known, y is not known. So there are two unknowns, so in principle I need two pieces of information to be able to find both x and y, yes? One piece of information is actually very evident, yes? What can I say?
That x over y is equal to 5/8.
Yeah, that's the non-trivial one. The trivial one is?
What are the variables?
No, the trivial one. What's the connection between x and y? The whole expression, the whole length is 12, so x plus y is 12.
Equal to 12.
Yes. So it means that, yes, we need two pieces of information. So Maximilian gave me the harder one, so, but you know that, you just learned that if A1 is equal to A2 based on the problem, so as you said, what I can conclude is that the relation, so the ratio of x over y is equal to 5/8. This is what we just learned today. Yes? But of course, there is also a very trivial one here. This part is x, this part is y, and we are given that the whole length is 12. So it means that BC is 12. So this means that, I forgot to write everything, for example, is in centimeters. And then this means that x plus y is equal to 12. So then this means that I am facing now, algebraically, I am facing a system of equations, yes? I have x over y is equal to 5/8, and I have x plus y is equal to 12. This is, of course, not a standard one, but immediately we can make it a standard by substitution method. For example, here, let me multiply both sides by y. If I multiply the left-hand side by y, what will be left for me is just x. And then when I multiply it by y, it becomes 5/8 times y. And then what I do, I substitute this x here, and then I will have one equation with one unknown. Then I find y, I put it back here, and I find my x. So if I put it here, it becomes 5/8y plus another y is equal to 12. To get rid of this fraction, so let me multiply everything by 8. This becomes 5y. If I multiply this by 8, it becomes 8y. And if I multiply this by 8, 96. So if I add them, it becomes 13y is equal to 96. And then y becomes 96 divided by 13 centimeters, for example, here. This is my y. And then I put it back into that equation to find x. So x becomes equal to 5/8 multiplied by y. Y is 96/13 centimeters, yes? But then immediately you see that this one and this one are simplified. So how much is left? It's 12, yes?
Yes.
8, yes, and that's correct. And then 12 times 5 is 60 divided by 13 centimeters. So it means that x is equal to 60/13 centimeters and y is equal to that number exactly. Yes, so that is one sort of problem here. There are some problems in the book. So let me use one of the problems in the book. I don't know why they have called it level 3 problem, but that's very simple, I think. So it is problem 4245. Problem 4245 on page 149. So I will try to draw it correctly, but it's not that easy. So here, okay, so A, B, C, and it is mentioned that, for example, this angle A1 is equal to angle A2. One more extra, we have one extra piece of information. We know that the length of AB is coincidentally equal to the length of DC. So we also know that AB is equal to DC. So this is what we know in this picture. Okay.
Yep.
And then we are supposed to show that it is mentioned here that AC times BD is equal to AB squared. Yeah, actually it's very, very simple. So we know that these two angles are the same. These two lengths, there is no guarantee that this length is equal to that length, but something has happened and these two lengths are also equal. Then we want to show that this relation holds. Okay, so what should we do here? Yes.
What I did is that I named like the sides, so like the two sides that are similar, I named it A, then I named AC B, and then BDC.
AC.
So I named AB and DC. I named them A,
Okay.
and then I named AC B,
Okay, then what?
and then BD C.
Okay, that's just naming, but what's the strategy?
Yeah, and then I used the method because I don't remember what part it's like. The division.
It's the ratio.
Yeah, the ratio.
So exactly, but so what you are saying is correct. So what we do here is actually, I don't know why they call it level 3, but we say that A1 is equal to A2. Sorry, it's equal to A2. So I can conclude that what we learned, BD over DC is equal to what? AB over AC. Yes?
Yeah.
Agree?
Yeah.
And then I told you several times, if you have two fractions, A over B equal to C over D, remember this by heart. A times D is equal to B times C. So then this means that AC times BD is equal to AB times DC. Yes? That's the consequence. And then we are very, very close to what we want to show. At least AC times BD appears in the relation. But the point is that on the right-hand side, I have AB times DC, and it has been anticipated by this designer of the problem. AB is given to BDC, so I continue. Instead of this AB, instead of DC, I can put AB again. So this becomes AB, which is my AB, but instead of DC, I put its equal, which is also AB. But everyone knows that if AB is a number and multiplied by the same number, it becomes that number to power 2. So now if you look here, this is equal to this, it's equal to this, and it's equal to that. So it means that this one is equal to that one. And that's exactly what we want to show. Yes? Okay, the next two problems, I think, so the next problem actually I solved that when I was teaching, but let me solve the last one. But instead of solving the last one, so let me just make it a little bit more complex. So let us assume that you have a trapezoid. A trapezoid is a quadrilateral so that two sides are parallel. So we have only one restriction. Two sides should be parallel. Okay. The other sides, if the other sides are also parallel, we call it, of course, a parallelogram. But parallelogram is also a particular form of a trapezoid. So trapezoid is that these two sides are parallel. Okay. So let me give you the length of this one on top, A, and let me give you the length of this bottom one to be B. And what we do, we find the midpoint of this line segment. For example, assume that this midpoint is M. So it means that I myself find M in a way that these two line segments be equal in length. And from that point, I draw a line parallel to these two. It doesn't matter which one because they are all parallel. So I draw a line parallel to that one, so that this line will go and intersect the opposite side, say that at N. I want to find a formula so that when I give you the value for A and the value for B, you can put these numbers in your formula and calculate the length of the blue line. Yes? So I want you to find a formula which enables me to immediately calculate the length of a MN if I give you A and if I give you B. Okay? So, for example, in the book, they have written it with numbers, but let us do it algebraically. Okay? So here, M is the midpoint. I draw a line parallel with these two. It will go and intersect the opposite side at some point N. I want to find the length of MN in terms of A and B. Yes?
Is M in the middle of that line?
We don't know, but it turns out yes. So it is not under my control. What I do, I take M to be in the middle,
Yeah.
and I just draw a parallel line. It can be shown that when it intersects, this is also in the middle. But you are not allowed to use it. If you want to use it, you have to prove it.
Okay. And even though this can't be used in the question, doesn't it mean that all the four sides are the same length?
No.
I mean, from the top to
No,
to
for
M.
example, like, no, then I don't understand what you mean. If you
Okay,
need
from the
length of
top
side,
to M, it's the same length as from M to the bottom. Doesn't that imply that it has the same length on the other side?
yes, so that's what you mean. No, but because so you want to show that you want to say that this length is equal to that length. Is that
Yeah.
what you mean?
Yep.
Yes, this length is equal to this length, but you are talking about this length and that. I don't know, you're talking about this length and that length.
But aren't those also the same?
I don't know. You need to have. Yes, I know that this is the same, but I want to see your argument about that.
Okay. Well, okay.
If you want to use such an idea, because it is not mentioned in the book, you have to convince me, yes, you are right, this is true.
But I have to convince you that it's
Yes,
true.
you need to have a proof for
Okay.
that.
Well, I don't have the proof for that.
Yeah, but might be those lines are good actually. They are not that far away because might be, I don't know. If I ask you this length and that length, they are the same.
Yeah.
But still, we need to convince. If they are the same, and then these two angles are also the same,
They are.
might be you should be able. That's the congruency which will come next. So might be you can show that these two triangles are congruent, and if they are congruent, it means that the hypotenuse are the same. That's one way. It's not very far away from proof, actually.
Okay.
But let us concentrate now on finding MN.
Yeah. Which question in the book was this?
This is 42, 48.
Okay.
It's not exactly that one, but it is very, very similar to that.
I mean, someone has drawn in my book and they made it into a triangle.
Might be that works, I don't know.
Yeah, that's a small trick.
I will not go that way because there is not enough space for me to go up. Hopefully that's not the only solution.
I mean, you did this shape a little bit different than how it is in the book.
Uh-huh.
It's the other side that's.
Yeah.
Well, they are the same.
Yeah, but the-
Really good. Okay,
yeah,
so
so
it's fairly old.
Okay, so how we can find MN?
How can we find MM? That's the great question.
Because here probably this theorem is not useful there. Because we don't have at least this is not the first thing comes to mind. There is no bisectors and things like that. At least we have something about parallel lines. So if you remember that version of Thales' theorem that I mentioned to you, and of course at least there is something related to parallel lines. Yes, if these two lines are parallel, we can say this one divided by this one is equal to this one divided by that one. But the problem is that we don't have a triangle here, even though we have parallel lines. So this might be the reason that they want to make it like a triangle so that they can use this by continuing this upward. I'm not saying that this is not working, but I was thinking to make triangle in a different way. They were using, might be this will also work, I don't know. But for example, what can we say? I was thinking that if we can draw a line parallel to this one from here. Yes, for example, I would say that let me take this point and draw a line parallel to this line. Okay, so then what happens here? Or the other way around. No, the other way around is better. Because still I don't know this is in the middle. Otherwise I will make life harder for myself. I take this point and draw a line parallel to this one. And then, so where is B? B is from here to here, don't get confused. And then let me call this one D. So this you need to write. At least this is good. Why? Because you see this structure that is familiar for us appearing here. Then the question is that, is this useful or not? If it is useful, I need to extract information from it. If it doesn't work, I need to throw it away and use another way, to think of another method. So do you think it will work?
did you make a parallelogram?
Yes, automatically it becomes parallelogram. Why? Because these two lines were parallel from the beginning. I myself drew this line parallel to this one. So this quadrilateral definitely becomes a parallelogram because of definition. This one is parallel to that one is also parallel to that one. Okay, so for example, can you tell me what is the length here? It shouldn't be hard because you told it's a parallelogram. When it's a parallelogram, what is the length here?
A.
It's A. Yes?
Because
Because if
B
this is
minus
A
A.
and this is a parallelogram, if that's A, this should be A. So what is left for this
B
part?
minus A.
B minus. So we already know that this is B minus.
Of course we do.
Yes? And now, let me give this a name, but you should be able to do that. I want to calculate MF. So I can use the Thales theorem, that version of Thales theorem. So let me give them names, A, B. So because MF is parallel to BD, I can write what? I can write AM. Because I want to make this involved, I shouldn't write AM over MB. Because in that case, I am not allowed to write MF over BD. So I write AM over the whole expression is equal to MF over BD. So let me wait to see if you understand that. So MF is parallel to BD. I can write two different ways. I can write this divided by that is equal to this divided by that, end of the story. I cannot say anything here. But if I want to say something about MF, I have to write AM over the whole AB. Then I can write AF over the whole AB, which I don't need, so I don't write it down. And then I write MF over BD, which I need, and I write it down. Yes? Is that understandable?
Hold up. Why is it AM over AB and not over MB?
The reason, Gustav, when I explain, you right.
I
And then when I stop, you need to see and then write.
Okay, but look at your picture you drew.
I told you there are two ways. That was the whole point of the lesson. I can write this divided by that, this divided by this, end of the story.
Yeah.
Or I should write this over the whole thing, this over the whole thing. Then I can write this over this.
Right.
So I'm using that version.
Okay.
Yes?
Now I get it.
Yeah, so listen and then write.
I tried.
It's a really bad thing to write down.
I disagree.
Yeah, you disagree, but that's just evidence.
It's good to have it written down so you can look at it later and be reminded of it.
Yeah,
it's also
but we have
good to
this
write it
in the
down, so-
recorded version.
But it's good to have to write it down so you get it into your muscle memory. Even though it
I
doesn't
doubt
work.
it. I doubt it because I would
Okay.
never able to concentrate on 2 points. Writing and listening at the same time is very hard for me.
Okay.
And seems it's hard for you too.
I'm just stupid.
No, that's not a
Generally.
stupidity, but that's some habit. I think, especially, it's very hard for men, I think, to concentrate on 2 tasks,
Yeah.
listening and talking at the same time.
Hashtag mankind.
Okay, let us see now how it goes. What is AM now? Can you tell me what is this? I don't know what is AM. I don't know what is AB, but I can say something about the whole thing.
1/2.
1/2, yes? Because whatever AM is, M is in the middle. So AM divided by AB is definitely 1/2. And then MF is over BD. Okay, but we already know BD, yes? BD is B minus A. So this means that this is something not from my side. This is on the board.
I was
Okay.
confused.
So then 1/2 is equal to MF over B minus A. But let me find MF. How? I multiply both sides by B minus A. Yes, so it becomes 1/2 times B minus A is equal to MF. At least this I would call it a progress. So I was able to find this part. This question mark is this.
And then Fn is equal to A also.
Yeah, Fn is also equal to A, yes? Because this is also a parallelogram. If that's A, this part is also A. And I am looking for finding Mn. So Mn becomes equal to MF plus Fn. MF, I got it here, it becomes 1/2 B minus A. And Fn, we realize it is equal to A. And then let us simplify it algebraically. So then it becomes 1/2 B minus 1/2 A, but I add 1A to it. 1A minus half of the A, it becomes positive 1/2 A, yes? And I think it's better to write it more compactly as A plus B. So that's a very nice relation. It's the average between them. So if you have a trapezoid with A and B as these bases, and then you want to find this line, then you immediately see that you can just add them and divide by 2. So for example, the problem in the book, the top one is given to be 50, the lower one is given to be 80, and then you're supposed to find that one. So you add 50 to 80 and divide it by 2. But of course, in the exam, you're not allowed to use that. You should be able to prove this.
So
Yes?
Mn is A plus B over 2.
Yes?
Okay.
Okay, so is that understandable?
Yeah, okay, yeah.
Okay, but I don't know, these problems could be really hard sometimes. Let me just use, if I can find some problem from one Persian book here. So that seems interesting for me. I saw it this morning, but I didn't think about it. Let me draw the picture here for you. Okay, it's here. So I can give you this one to see these problems can be really hard. And of course, trying to solve these problems teaches you actually a lot. So your skills will improve even in algebra, not just geometry. The way that you think logically will be improved. Of course, they haven't given any pictures. They have given text. From the text, you need to draw the picture. But let me just draw a picture for you here. So I have a parallelogram here.
Isn't the text in Persian?
Yes.
Yeah. So, okay.
So A,
You could just write that down, and we can take it from there.
B, C, and D. So, and then they have mentioned, so let me just draw a picture for you here. So take this vertex and just draw any line that you like. For example, this line will go like this, and then it will intersect AD. Let me just mention it correctly. AD at F. And then the continuation of AB at E. So this black one, this black quadrilateral is a parallelogram. I just chose this vertex, for example, and I drew a line so that this line and goes and intersects AD at some point, I call it F, and then it continues, it will intersect the continuation of AB at some point E. And then, according to this problem, you are supposed to show that if I measure AB and then divide it by AE, and I do the same for AD and AF, and if I add these two fractions, it becomes exactly equal to 1.
The question says that.
Yes. Okay, this is what we want to show in this picture. So we don't know anything about sizes at all. So we just have an arbitrary parallelogram. So this is in this picture. You want to show that even if I don't know the values of these things individually, I know that this fraction plus that fraction is exactly equal to 1. Okay, let us try to think about the problem here myself. So there is only one piece of information. A, B, C, D is a parallelogram. So you don't know if F is in the middle or not. Apparently in this picture it is not in the middle. We don't know anything. If you want to say a word, you have to prove it first yourself.
Does it mean all the sides have the same length?
Which sides? No.
Allah.
When you say parallelogram, it means AB and DC have the same length. AD and BC have the same length. We cannot say it more than that. We don't know anything about this length. If you have a suspicion that there is something going on, you need to have a proof for that. So even I don't know if I can solve the problem on top of my head right now, but let us see how it goes.
I believe it has something to do with ratio.
Yeah, definitely, because at least I see the structure of the triangle here. You see,
Yeah.
this one is parallel to that one. So I can use that version of Thales theorem, might be. Or, for example, might be there are some similar triangles involved. You need to discover them first and then use them. So that's hard, complex problem. So you need to think about different aspects and try to merge them in some way that gives rise to this one. So let me double check that I have written everything correctly, because otherwise that would be annoying.
I got really close.
Yes, I will check yours. But please, everyone, think about the problem. Of course, these problems at this level will not be in the exam, but don't think about the exam. This is important to think about your brain. Yes?
Well, so I multiply by. I'm not getting a 1 anywhere. Because these are the same numbers. This is just the inverse of this. But I'm the one difference is that I have EB and they have AB.
EB, where is EB changing? Oh, okay, EB In
Because it was this to this, and then this to that.
yeah, that's a little bit a strange combination. I myself need to think. Yes.
So from the shape, I can see that we get a backwards C.
What?
I see like there's a backwards kind of C, the Z.
Yes.
So from that I could say that DCE,
Yes.
the angle is equal to FEA.
FEA,
Wait, DC.
DCE. Yes, they are
Yeah.
equal. Yes.
Yeah, and then
Yes, you are right.
yeah, EFA
Hold up
is
now.
equal to DFC.
Not equal, similar.
Similar.
Yes.
Yeah.
That's a good discovery. Might be it helpful.
Wait. Okay.
Like also EFA and DFC.
Yeah, I
You don't
found
need
that.
to. Yes, you don't, yes, exactly. So this
So-
angle, what you are saying is this equal to this angle because this is a pair of vertical angles.
Yes.
Yes.
Yes, that's correct.
And then
And then you discover this backward z, which is nice. Something like
Exactly.
that. So then this means that this angle is equal to that angle.
so
So then this means this bigger triangle that you see here, based on angle theory, is similar to this smaller piece.
yeah.
Yes, that's a good discovery, and probably this will help, definitely. I haven't figured this out myself, but definitely this is useful. And probably another useful thing is what? Is this Taylor's theorem, yes? Because now you have this setup here, you have this setup, and this line here, this line is parallel to this one. This will give you some ratio between these two according to Taylor's theorem. So might be you need to merge them together so that you can come up with this answer. But I think that's a very nice discovery. So if you want to use it in the exam, you have to exactly say what you said. You need to say that this is equal to this based on what, this is equal to this based on what, so then by angle theory they are similar.
What did this Z what was there a word for it?
Yeah, parallel and transversal.
Parallel transversal.
So for example, let us explore the consequences of your discovery. Okay, and then by the way, because writing AB and AE is hard for me, so let us give them names. For example, if you don't mind, let me call this AB X. By the way, if I call this X, immediately what can I call for DC?
X.
X. That's good to know. Don't write more letters than necessary. It's important, by the way. If you call this X, of course you can call this Y, but if you know that they are the same, don't do that. Write it X again. This will help a lot. Okay, so what you said is completely right, so I don't write it down on the board formally. We know that these two triangles are similar. So can you tell me, what can I write? What can I write the ratio? So in principle, I have three ratios. For the hard problems, it is not clear which one might be useful. So let us write all of them. Of course, we have a hunch for that, yes? Because here you have AD. What is AD? AD is unfortunately from here to here. And AF is from here to here. I don't know. But then we have here AB, which is from here to here, over AE. Okay? So let us explore what are the consequences. At least you can tell me what should I write. Can you tell me yourself, Maximilian, what can I write for ratios? And then for the ratios, I recommend you like that. Let's concentrate, for example, on the smaller one. There are 3 sides for that. One of them is AE. The other one is, for example, AF. And the other one is which one? EF. Okay?
Yeah.
Apparently, EF is not very useful here. Okay, but let me practice. What should I write below AE from the bigger triangle?
FC.
AE is this one. If you immediately rotate it in your brain,
X.
Yeah.
so it would be DC.
Oh.
Yes? Or do you agree or not? Another way, AE is opposite to F. This one is equal to this one. What is the opposite one? DC. That's also one way. So I would write DC here, but DC is
X.
X. So let me call X. And then if I write AF here, pardon?
You said DC.
DC. So AF, AF, DC, yes. No. We don't get confused. AF is this one.
No, he said for the last question.
Okay, so what should I write? Below AF.
I'd say FD.
Below AF, I need to write FD. Yes, exactly.
Yeah.
So I need to write FD here. And of course, if I write EF, then it is clear what should I write. I should
No,
write.
I was lagging behind.
Yes, no problems. No problems, thank you. So it becomes FC. But it seems that we don't need this part, yes? Apparently, I don't know, intuitively it seems that even though it's true, we don't need that. Here, the bad point is that this EF, this AE is below in the denominator. The way that I wrote it carelessly, I put AE in the denominator. So now we can use your trick, yes? What we can do,
I have a trick.
yes, we can interchange them.
But
So it
then that
becomes
means that
X
they
over
introduce the
AE.
second one.
Yes,
Yeah.
it becomes FD over AF. At least it is somehow a little bit good because at least I don't know. You see, I don't know how to solve the problem. I'm thinking loudly. So at least I have AE in the denominator
And
in the
AF.
denominator. Yes, yeah. Okay.
Kind of.
So that is something. By the way, let me translate this. What is AD? AD is unfortunately from here to here. We haven't any name for that.
Let's
And
use
then
Y.
what is AD?
We could say that
So,
AD is
no,
Y.
so AB is X. AB is exactly X. By the way, we got it.
Yeah.
So it's very nice. Okay, so you see, it's very good, by the way. Why? Because the denominators. Okay, so let me start from the left-hand side. Instead of AB, I put X. So this is X over AE. But we learned that X over AE has another name, yes? Instead of X over AE, what can I write? I can write FD over AF. Yes? Agree?
Yeah.
Plus, I repeat this part again. But now this is much better than the previous situation because here I had 2 fractions. The denominators are not the same. But by the method that Maximilian actually told us, we learned that this one can be written in a way that its denominator matches with the denominator of this one. And then it becomes much simpler because I can put just one denominator there and I add them. So it becomes FD plus AD. Yes?
Okay, but since FD plus AD over AF is supposed to equal to 1, is
Yeah.
FD plus AD also AF?
It should be, you are right. Otherwise, this means that the problem is wrong or I read it wrong. Yes? Is that the same or not? It is not, you are right. So I think now it is clear that the problem is wrong. Yes? Because you see, because what we said, if we are confident about what we have done there, yes, which I believe that we are confident, then it means that if the problem is right, this left-hand side should be equal to 1. Instead of AB over AE, AB is X. So I write, yes, I write X over AE, I write FD plus AF, and the denominators become the same, so I'm adding them. Is this equal to AF? Clearly not, yes, because AF is from here to here, I don't know. So why they have made this mistake here?
Have they made?
Yeah, it is clear. No, I'm completely sure. So if this is going to be the case,
Bobak, I'm confused where you got FD and AF from.
if the AF is on the board, yes?
Okay.
So
Okay.
instead of this one, I wrote that.
Okay.
And
Now
then-
I get it.
Yeah, but this is not correct, unfortunately, because FD plus AD, FD is from here to here. It should be somehow AF plus FD is AF, which is not correct. But yeah, this is not correct, definitely. Might
So-
be I have translated it in the wrong way.
Well, it is your first language, so
No, I mean that
I'd assume you know it.
because they have written that there is an arbitrary line that you draw from vertex C of parallelogram ABCD so that it intersects AB at E and intersects AD at F. Then prove this. AB over AE plus AD over AF is equal to 1. Okay, now I realize might be they were a little bit careless. Might be we, if we draw it in a different way, it will work. Yes. So they
Why
didn't
would
know. So
Is there a picture attached?
no, there is no picture. That's what this they need to be careful if because they have. I just chose this one for you, but let us check this one. If from here, instead of drawing a line from here, so let me just draw a line from here. Then what will happen? Okay, so this will go, and then this will intersect this at F. Yes, according to that.
Wasn't it supposed to intersect with AB?
Yes, but then AB will be here.
The other
So
side.
that's what I'm saying. That if this is going to work here, then they have to be careful. They are not allowed to say that language here, because here, if I draw this one, might be in this case this is correct. I don't know. So if I continue, this becomes F, and then if I continue, this becomes E, and then this is A, B, and C, and D. And then let us now see. Do you think that in this picture we will have this AB over AE, yes, is plus AD over AF is equal to 1? Might be it is sensitive to how you draw the diagram. If it is sensitive to how you draw this picture, then they are not allowed to just write it in words. They have to mention exactly what they mean. But do you think, let us think about this problem. Do you think this is correct here? I am doing the same thing. Instead of drawing this line inside the parallelogram, let me draw this line outside the parallelogram. And then name F the intersection between this line and AD, which of course in this case I have to continue. And then let me call E here. But do you think now in this picture, this relation is correct? Let us discover that. It shouldn't be hard. We can just use the same tricks, I think. Okay.
But is EF parallel to anything?
No. It's not parallel to anything.
Okay.
So let me just call this one X, and then this one also becomes X. But now, Maximilian, can you discover another pair of parallel, similar triangles here? If that would be the case. So let me see, AB over AE, yes, is equal to plus AD over AF. So here we have this one is parallel to, is similar to this one. Do you agree?
Yeah.
Why is that?
They're
Because these two lines are parallel, and this is the transversal. So this means that this angle is equal to that angle. Yes?
Yeah.
And then this time, these two are parallel, and then this is the transversal. So this means that this angle
But isn't
should be
C1
equal to this angle.
Isn't C1 equal to C2?
No.
And why is that not this? What is that? Why is that not? What is it?
Because this is not this pair. They are not on the same. I don't know how to say.
Okay.
Why should they be equal?
No, because
This is something like this, and this is something like this. So why this should be equal to that?
I needed clear for me. I didn't see it, but now I do.
Okay. So they are not equal, but
Okay.
this one is equal to that one, and this one is equal to this one. So again, these two triangles are similar. So if that is similar, what can I write? I can write BE over DC, which is X, but let me write AB and AE involved. Now, here in this case, this is not useful, actually. Even though this similarity is correct, but it seems to be useless. Okay, now I understand. So let me just do it. We can say that the length, because now let us see this Taylor's theorem in this context. You see here, and then let me draw this line here. Okay, and then I can say that the ratio of AB over AE, AB is from here to here, which is, so we have this situation. It's a little bit confusing, huh? AD plus over AF. Okay. So I want to have AB over the whole AE. Okay, so let me start from this scenario. AD over the whole AF.
What if you connect
So let's just think.
B and B?
And then this becomes equal to this, which is useless again.
I think that's more for you.
AB and
What if you?
so I write this is equal to
Ja, det är det jag gör. Ja.
AD.
Fast på andra sätt än jag tror.
I would write it as FD. Let me see. FD over AF. Then it becomes X over the whole AE. Yeah, that is correct. Okay. Now, X over. So you see, that is exactly the same relation again.
Yeah.
It's very surprising. But I will describe it when I understood it myself. So let me see if it works or not. The left-hand side becomes equal this time. Instead of AB over AE, I write FD over AF plus, and then I repeat it, AD over AF. But do you think in this picture this is correct, that this is AF again? FD plus AD. Where is it? Where is FD?
Yeah.
FD is here. Where is AD? Yeah, in this picture it works.
Yeah.
So they were careless when they were designing the question. So because the questions written in words shouldn't depend in the way that you draw the picture. If it depends, they have to mention it explicitly that you are not allowed to choose this line inside the parallelogram. So you see that in the when they say draw a line from C, it might be the case that I draw this line. Why not? If they insist that this is not correct, they should mention it. So now let us describe it for you here. Okay, so let me clean this one. So you see that I was myself confused, and we discovered something new. The people didn't know about that they are designed the question in the wrong way. So we learned that this is not a very good question. But let me just try to tell you why this is correct. Okay, so let us see why we have this correct. So first of all, do you agree that if I call this one X, I can call this one X as well?
Yes.
Yes. And now let us look at this setup. If I write this, do you agree with me? So look at this big triangle here. And then momentarily don't look here. This line is parallel to that line. So I can use the Taylor's theorem, yes? I can write the ratio of FD, to the whole expression, yes? To the whole AF is equal to, okay, DC, okay, can you tell me what should I write below it? AB. AE. Do you agree?
Yeah.
AB. So the ratio of FD over FA is equal to DC over AE. So this is what I discovered. Okay? But what is the name of DC? The name of DC is X. So I can call it X. Yes.
That's the same thing we got before.
Yes. Now let us start. I want to show this is correct. The left-hand side is equal to AB. What can I call about AB? Do you agree? If I call DC X, I am allowed to call AB X as well.
Yes.
So instead of AB, I can write X. Instead of AE, I just write AE. And then I copy and paste everything. AD over AF. Then I continue. I discovered that X over AE has a better name in this context. Instead of this, I put this expression. So this becomes FD plus AF plus AD over AF. Now the good point is that the denominators become exactly equal. And then I am allowed to add them. FD plus AD. But in this new setup, FD is from here to here. And then plus AD, which is from here to here. It becomes the whole AF. Yes? So in the numerator, instead of FD plus AD, I can put a whole AF. And in the denominator, I have AF. And needless to say, whatever AF is, this fraction is equal to 1. And it is the right-hand side. So you see, we didn't give up. So we detected this error. It was not correct if I draw the picture in this way. But it becomes correct if I draw the picture in that way. Yes? But now can you tell me, if I draw it in this picture, how can I write the correct version here? So assume that I want to write something for this picture. I think the right context would be that I make this one
Minus?
Yes, this one minus. I think if I give you this minus, this positive, it will work, yes? Let us check. Because what we discovered was completely right using your method here. So, but let us discover this. It becomes X over AE, which was FD over AF as before, with the negative sign this time, plus AD. And then what happens, this time it becomes AD minus FD over AF. So what is AD minus FD? Yeah, it is correct. AD is the big one, minus FD, which is this one. What is left is AF. And AF divided by AF once more is 1. So now we learn that if we draw the picture in this way, we have to change it with positive sign. So the positive sign is correct for this setup. But if I want to write something correct for this setup, I have to ask you to show this. So in this picture, this is the correct relation. But in this picture, that was the correct relation from the beginning. Yes? So, but you see, I just want you to understand that this is not the case that if I am experienced by looking at the problem, I can solve it immediately. But I don't know, do you want to have another test here again?
Yeah.
But I don't trust the book anymore now. Because the bad point is that you try hard and then the problem was that it was not hard for me to discover the correct version, but sometimes it is extremely hard to find the correct version. But anyway, any questions here? Did you understand what's going on?
Yes.
Yeah. Mostly.
By the way, I really like geometry. So you really need to be very smart to detect how you need to do. These are problems, simple problems. They can be extremely hard.
These are simple problems, you say? What a funny joke. That is a funny joke.
It's no, because I think you were able, for example, you discovered the relation. So more or less what you said was completely right. I followed you exactly.
Yeah, but are there these kinds of problems with like 3D shapes?
Yes, of course. That is called solid geometry.
And
This is plane geometry.
when do you study solid geometry?
You don't study that much, except that you just measure the volumes, areas, and things like that. Not that much attention is paid to geometry these days. I don't know why, but anyway.
Okay.
So let us see if I can find a problem here. Because in geometry, I don't dare to randomly choose something because it might happen that I myself cannot solve it, at least
No, that
under
has
this
never
time.
happened.
But it seems to be nice. So here, let me just again translate it. So we have a trapezoid.
Trapezium.
Yeah, that's the British probably name.
I think it is.
Yes. So this is the trapezoid we have, A, B, C, D. And by the way, if you read geometry books, if they say A, B, C, D, do not name it A, B, C, D. It's a convention. You need to either go clockwise or anti-clockwise. That's up to you, but you need to respect that. From P, which is the intersection of the diagonals. So we have a diagonal here. Drawing nice pictures are very instructive when you're solving geometry.
Let's see.
So this is a diagonal, and you have another diagonal here. And then the intersection point, according to the problem, is called P. They are saying that from P, we draw a line which is parallel to AB. So let me change my color. We draw a line from P, which is parallel to AB. So automatically it also becomes parallel to BC. So that it intersects, where is it? It intersects these two sides, AD and BC, respectively at E and F. So AD at E, BC at F. So what you know is that this blue line is parallel to AB and automatically parallel to BC, and those are just diagonals of this trapezium. And then, I don't know, you are supposed to show that two parts. I think the first part is a hint for the harder part. So you are supposed to show that EP is equal to PF. And then number two, you are supposed to show that 2 divided by the length of EF is equal, hopefully this is right this time, AB plus 1 over CD.
Or the lines that go through AC and BD bisectors.
No, we don't know. By the way, whenever I sell something, if you think that should be bisector, you need to be able to prove it. You cannot rely on the picture. And in this picture, these big ones are equal, but there is no guarantee that these two pieces are the same. There is no guarantee. So my impression is that usually if the problem is 2 parts, the first part in hard problems is the hint for the second part. So let us see, let us just concentrate on the simpler one. How do you show that EP is equal to PF? By the way, it's very nice. It was not trivial, yes? If this is correct, not wrong, because I can draw the trapezoid in a very exaggerated way like that. But apparently it doesn't matter. If I draw if what they are claiming is that if you draw the diagonals, and if you put P here, and if you draw this line parallel, again, this part is equal to that part.
So is that a convention?
No, not convention. This cannot be a convention. There is a fact to it. So you see, it means that this is a discovery in a trapezoid, yes? It means that whatever you have as your trapezoid, it doesn't rely on the shape of the trapezoid. This property is a property of all trapezoids, not just the one that I drew here, but even in this very bad picture, you more or less, yeah, you can make sure that this is also equal to. We want to show that this is not coincidence. This happens all the time for trapezoids. Do you have any idea how to do that? Yeah, it might be hard, I don't know.
Give me a minute.
I mean, I'm seeing the Z shapes again.
Okay, there are many Z's now involved.
Yeah.
Let us think.
So, to clarify that I understand the thing you're saying with the z's, that would mean that ADB, the internal
ADB, yes.
side angle,
That
is the same as DBC. Is that what the z?
D,
Or is it DBA? What are the two similar angles?
no, I don't see that, but I see that this angle here is equal to this angle.
Yeah.
Okay.
This is a Z right now.
Okay.
Yes.
And
Color
then
from Mingula, it's really good.
BAC is equal
That's the same
to,
backward.
like the angle is equal to
There's one,
BC.
Wow.
Yes.
Yeah.
Yeah. That's also
So
correct.
that means that the triangle DPC
Yeah.
is a isosceles because they have two similar.
No, isosceles. I am a little bit doubtful here. So
I
no,
don't
no,
think
no.
you can.
no, there is no,
no.
there is no isosceles involved.
Yeah,
Unless- Unless this leg is exactly equal to this side.
no, I realized my mistake.
I think of the other trapezoid you draw.
Yeah.
You drew. You could, if this is a rule that works on every trapezoid, it should also work on the other.
Yeah.
And on the other, it would just look wrong.
Yeah,
And
exactly.
so it doesn't work.
Exactly. Might be that's why it's better to draw that picture instead of that picture. It's a little bit confusing because all the time you want to see that they are equal, but they are not.
So
But you see, this is not an easy problem. We want to show that EP is equal to PF, regardless of the way that we draw the trapezoid. Okay, so it should be somehow related to what we have learned so far. So EP over AB is this one over that. Yes. Let me just think a little bit.
it would seem that
These
they
are similar.
yeah. It would seem that ABP and DBC are similar.
They are similar.
Yes. Maybe you could go from there.
The reason that I didn't go for that, even though I immediately detected that, because none of these line segments are involved in those triangles, unfortunately. So what you are saying is right. This upper triangle here,
Yeah.
I detected immediately it is similar to that one, but the sides are BP, PA, and AB, and the sides are, none of them involves EP and PF. Even so, this is a tempting thing. That's the hard part of problems. If you discover something, it's useless.
Right
But
now, I'm just
now I
trying to find
discovered
the-
what we can do. Yeah, try to help me to solve the problem for you. Okay, so this you need to understand this pattern quite good. So if I write something like this, do you agree with me or not? So let me make it a little bit fun for you. So here I will write it DE, but you tell me why. Is over DA is equal to EP over AB. Do you agree with what I have written?
Why not AE?
No, just there are many things, but do you agree with this one?
Kinda.
Because you see here, you should train your eyes.
Yeah.
You see,
Yeah.
this is D, and this is your P, this is your E, this is your A, and this is your B. I have
Yeah.
written DE over DA is equal to EP over AB. Do you agree with that? So
I
this is
agree.
possible, yes? Okay, now let me write something similar for you. If I write CF over CB, now can you complete it for me here if you understood the previous one?
FP
Yes?
and BP.
No, be careful. So this is the other way around.
Oh.
So I have written CF
So
over
many
CB. So what you write then?
AB,
PF,
PF, AB.
AB again. Exactly. Yes? Do you agree with these two?
Yes.
Now, my impression is that, let me think why a little bit loudly.
Wait,
If I can show these two things are equal, then I am done.
Did
Yes.
you write PE or PF?
Yes, you are right. Okay, now, do you agree that if I can show that this one is equal to this one, I am done?
No. Explain that, please.
No, everything I don't want to explain, you should say.
Okay, in that
If I
case,
show that
don't
this fraction is equal to this fraction, I am done. Why?
know.
Because if this fraction, if there is a b, yes?
AB is in the denominator of
Yeah,
both,
we can
and
just
we're proving that.
So we are done, yes? Because if this one is equal to this one, this means that EP over AB is also equal to PF over AB. Do you agree?
Yeah.
And then because the
Okay.
denominators are the same, I can cancel them, and what is left for me is exactly what I want to show. Okay. So I am not saying that this might help. This is one strategy. Okay, so this is a lot of scratch work. If the problem is hard, this is a scratch work, a scratch paper work. Okay, so now let us try to concentrate to show that can I prove that this is equal to that? You might say this new problem is harder than the previous one, but I wouldn't say so. If you see how you can show that DE over DA, DE over DA is equal to CF over CB. If I can show that, then I am done.
We're back here to prove that the BC and AD are the same.
Well,
Same
No,
level.
they are not the same. The ratios are going to
Okay.
be the same.
because if
Right.
because EF is parallel then to DC and AB,
Yes.
and
Did we do this? Didn't we do this exact question like a half hour?
It was similar, yes. So that's why
we're proving a different thing though.
Yeah, so but let us concentrate. I'm not saying that this is the only way, but this is one way I thought about, and I think I am convinced I can show that these two are equal. If I can show that these two are equal, then this means the right-hand sides are equal, the denominators are the same, so I get exactly what I need. But there is a big if. Are these two fractions equal? Okay. Are they?
Yes,
So how are you convinced? So
because APB and DPC are similar triangles. So
Yeah.
then their height to base ratio would be
but they haven't studied that. So I need to. That's my difficulty when I teach the lower classes. I have to use the theorems they have studied.
But he does have a point. Like,
Yeah.
it's the same ratio.
So you are right. You can use the ratio of the heights, the ratio of a lot of things, but that's not based on what you have learned. So that makes the problem even harder because you have to I have to provide a reason that you have studied. Okay, but let me see if there is another way. Okay, so for example, if I write AE over ED is equal to
Oh, we use the other convention.
AP over PC. Do you agree? AE is from here to here divided by this is equal to AP over PC. Yes? Yes or no? This
yeah,
should be
okay.
easy to detect.
Yeah.
Yes. This
Yeah.
one divided by this one is equal to this one divided by that.
This is the second. No.
Let's forget
first.
about the name. This is true. Yes.
Okay. Yeah.
And then you go here and now look at it upside down. This is the scenario. This one, I would write CF over FB is equal to what? CP over PA. Do you agree? Yes, the same scenario. This one divided by that is equal to this one
Okay. Yeah.
divided by that. Yes? But now, very interesting things happen here. This is AP. Don't get confused. AP and PA are the same. Yes, AP and PA are the same. PC and CP are the same. So the only difference is that to use Gustav's trick to raise it the other way around. So it becomes CP over PA. Now this is the patent under your name. ED over AD. Yes?
I should. Yeah.
Is that understandable?
I should patent.
Now what you can conclude, you see CP over PA on the one hand is equal to this, on the other hand is equal to that.
Yeah.
So it means that what is the conclusion coming out from here is that ED over AE is equal to what? CF over FB. Yes?
Yeah. Yeah.
Okay. Now, I think we can do it actually. So, yes. So what is left for me is, let us start from here. For example, here, CF over CB. Let me start CF over CB. CF over CB. So let me start with CD over CF. Instead of CB, I can write, look at the picture. Instead of CB, I can write CF plus FB divided by CF. And then I can divide CF over CF and then plus FB over CF. But CF plus CF is just 1 plus, instead of FB over CF, what can I write? FB over CF is AE over ED. Yes?
Yeah.
And then instead of 1, the trick is to write ED over ED plus AE over ED. And then this is the common denominator now. And ED plus AE, look at the picture. ED plus AE is AD. So I was able to show that CB over CF is equal to AD over ED.
This is confusing.
Yes, it is confusing.
How did you get from CF over CF to 1 and FB over
okay.
CF to
Okay,
AE?
let me try to teach you a little bit. So, might be okay. So now everything is. I'm convinced that everything is correct. Okay, so what we want to do. Let me start from scratch again.
From scratch. Oh, yeah.
Yeah, so let me start from the correct version. I don't want to go up and down so many times. Okay. So let me start from here. Okay. So CB, my goal. Let me start from CB over CF. Okay. Look at this picture. Instead of CB, am I allowed to write CF plus FB? Yes. Instead of CB, I am allowed to write CF plus FB. Divided by CF.
That I
But
understood.
according to algebra, I can write this divided by that plus this divided by that.
Yeah.
This is algebra.
So far, so good.
Yes. And then CF over CF is what?
It's 1.
It's 1 plus FB over CF.
Yeah.
But now
This I get.
let us go back here. Let me go back here. Let me clean everything here and do it again. So did you agree with this one when I wrote it? And did you agree with this one when I wrote it?
Yes, I did.
Okay. So now let me use this trick because I see that I need FB over CF, but I got CF over FB. So this gives me that I can do this the other way around. So I can write it as what? FB over CF becomes equal to AP
Gustav
over
convention.
C. Yes,
Yeah.
Gustav actually method. Okay, and then compare these two.
Yeah, they're the same.
They are the same, so it means that AE over ED is also equal to this expression, yes?
And you switch the PA to AP because they're the same.
Yes, they are the same.
Okay.
Yes? Is that understandable?
Now
So
I
from
follow.
here we got that. We already had this one. The right-hand sides are the same, so the left-hand sides has to be the same.
Yeah.
Yes?
I get it.
Now go back and put it back here. Instead of 1, I just write 1. Instead of FB over CF, I am allowed to write what? AE over ED. Yes?
Yes.
But now, instead of 1, I write ED over ED.
It doesn't matter what you
No,
write.
because I want to make the denominators the same. Yes? And I copy and paste the second part. Now that the denominators are the same, so I can write one denominator and I add ED and AE. And let us go back to the picture. What is this one? ED from E to D, from A to E. ED, AE. If I add them, it becomes AD. So I can write AD in the numerator.
Okay.
Understandable.
Yes, it's understandable.
Understandable.
Now, so what we showed that CB over CF. So let me write it. We showed that CB over CF is equal to the last expression, AD over ED. Again, Gustav convention of method. So CF over CB is also ED over A. Yes?
Yeah.
Now go back. CF CB is this part. ED DA is this part.
Yeah.
They are equal. When they are equal, these two should be equal. When they are equal, the denominators are equal, the numerators have to be equal. This means that this is correct.
Okay, what about the second?
Wait. Yeah. Stop right there. How did you get from AD over ED to EP equals PF?
This one is equal to this one based on this.
Okay, wait. Okay.
Then you conclude that these two are the same.
And since they both have AB in the bottom. Okay.
Yes, then it means that the numerator should be the same.
Now.
And then this means that PF is equal to EP.
Okay.
So you see, this might be considered as a hard problem. Yeah.
Yeah.
But of course, the hard thing for me is that of course I know a lot of theorems, but I'm not allowed to use them. It makes my job harder.
It's like
Yes,
Cameron over
because,
here.
yes, because I need to find a way that is exactly according to the theorems that you have studied, and it makes life harder for me. But then I think if you are interested, you shouldn't be able to sleep until you solve the other part. Might be in the second part, you need to use this part. So now, this is a theorem, but it is not that important theorem that people doesn't mention it. So I didn't know about this property of a trapezoid before solving this problem. But now I realize that this is a property that now we discovered actually. They are always the same. But now there is no time for solving the second part, probably it's harder. And you need to find a way that you can find this way. I even don't know where to start from. Yes, because it's 2 over EF. Okay, so this I have a hunch here. So 2E over EF, what is that?
1 over EF plus 1 over EF. If you want to split it, because
yeah, so might be that's correct. But I was thinking instead of 2 over EF, I can write 1 over EF divided by 2.
How is that better?
Because EF divided by 2, I understand what is EF divided by 2.
It's EP or
It is
PF.
just one of them.
Okay.
And then instead of working in trapezoid, you can just work in a triangle. Might be this is a clue. I don't know. This is just, it came to my mind. I'm not saying that this is probably correct. But I don't see how can I find a 1 on top here. Okay, because there is no 1 here in this problem. We don't know any length. Is it 1 or not? So this 1 should appear a little bit differently.
Will we continue with this tomorrow?
Yes, I will. No, not probably with this tomorrow. I want to teach concrete, but I just want to give you a flavor that geometry could be really, really fun and extremely hard.
You should just write EF divided by 2 as EP.
Yes, you can write. No, this becomes 1 over EP now.
Oh, yeah.
Yes, so you need to show that 1 over EP is equal to 1 over... This is a nice relation, by the way. How many of you knew about this relation in any trapezoid? Yes, so in any trapezoid, 1 over EP is 1 over this, 1 over this. It's very nice, yes? Yeah, this is called harmonic mean. So do you remember, if I ask you what is the length of EF we discovered today, it is the average between these two. That's called arithmetic mean. If you divide by 2, if you divide by 2, it's called arithmetic mean. This means that EF is a harmonic mean between the A, B, and C. Okay, so you can think about this. If you are interested, I also can think about it. We can at some point come to this one.
Harmony in math.
Yeah, it's harmony. Thank you very much for the people at home. If you are interested, you can also work with this problem. Okay, and in those sessions that are left after exam, might be we will be able to solve some of these problems and enjoy. Okay?
Can we watch a math movie?
Yeah, we can do that. Why not? Bye bye.
But do you know what